So with that, were there any other questions that we had about the architecture? Were there any questions that we had about the integration into the rest of the Cisco footprint?
I've got one, yeah.
What's that?
So just as like a customer who wants to order a FlexPod kind of ready to go, so what would be the process? Do I just say, hey, I need 10 servers with a bunch of storage and stuff, and then that's kind of laid out in a rack and kind of shipped to a data center? Is that powered and cable and everything?
So we, FlexPod for us is a 100% partner-led effort, right? So there is generally a workflow that says either here's what I'm replacing, right? Here's all the stuff that I have on the floor and I'm doing a refresh. And so we take kind of the net capacity of what they have and we uplift it slightly to make sure that we've got the ability to add new workloads as we go in. But generally when we're talking data center sizing, it's 4 variables, right? It's how much CPU, how much RAM, how much performance, and how much capacity do we need. And we've got tons of sizing tools. We run the requirements for the customer through those sizing tools. Based on those, we can generally tell how much upstream bandwidth they're going to need to connect those top-of-rack switches back into their core, right back into the spine, whatever topology it is that they're running inside the data center. And then that would all come as a product, right? So it comes inside the fancy cabinets with the graphics on the side of it and all of the cable management. There's actually a full rack, a full solid fire, or a FlexPod SF rack down in the CDW booth on the show floor. Right, so that's kind of that's the type of partner that we would work with, and that's the work product that they would do. So we know that what customers want to do is they want to worry about the platform, they want to worry about the VMware or OpenStack platform that sits on top of it, and they want to worry about the workloads. All the rest of the crap that goes into what's the radius of the bends on my cabling that has to go from this piece to this piece, what SFPs do I need to buy? The CVD, which is the reference architecture that lists every piece of everything and how it plugs together, defines what those are, and then the partner would take those pieces and deliver them as a product.
So it would be pre-cabled, pre-powered.
Yep.
Pretty much just
and it doesn't have to be, right? So most customers who are delivering into a greenfield or are doing a full refresh, that's what they would get. If a customer already has UCSB on the floor, right? They tried it for a pilot for some application that they were running. They like it. They want to expand it into something that's running their data center. If they come to their partner, if they come to NetApp and say, I want this and the network and the storage in a way that I can have all of that supported in one place, because God knows I don't want to have to, I don't want to have to deal with all of that independently. We can use that CVD to help them expand that out into a supported configuration and then roll them into one of those 3 support types that Lee talked about in his. So we want to be able to have the flexibility in there to say some customers want to up-level from where they are into a FlexPod. Most of the customers are going to buy a FlexPod either for a specific workload, specific location, or a refresh process.
I know it comes with all the logos on the side. Can you do racing stripes as well?
we can. I've got blacklight paint we can use. We can bring big red silk sheets and you can pull them off in the data center. Yeah, we'll. Tom is a fan, so I'm certainly going to suggest that to product management.
Jeremiah.
Yes, sir.
Customization taken via POs. So.
Right.
Write your notes.
I had a question.
Surcharges may apply.
That's right.
I had a question about scale.
Sure.
So there's a very defined switch that you're using at the top. You said you can scale up to 40 storage nodes.
Yes.
That doesn't leave a whole lot of ports for compute side. So what is the limitation there? Like, is it just X number of B series chassis, or what's the?
The CVD has to be a fixed config, right? So the CVD, the thing that we certify with Cisco that takes 6 months to do and a gargantuan stack of cache to get finished across lab teams on both sides, we have to have a fixed point. And so when we talk about the things that are specifically included in the CVD, those are the things that we validated and tested. If a customer wanted to move to larger top-of-rack switches, if they wanted to move to larger fabric interconnects, right, they could do that. Now the top-of-rack switches, the fabric interconnects are only going to trunk up to them. The B series are going to connect into the fabric interconnects. Right, so if there were C series in the cabinet, then those still plug into the fabric
FIs are uplink. Yeah.
Right. So if I needed more bandwidth between the top of the rack and the fabric interconnects, I would burn Nexus ports. and then every SolidFire node is going to burn 2 Nexus ports. So from a design standpoint, we can max the config with directly how it's written in the CVD. You're right, there's not a whole lot of wiggle room in there, and if those weren't just top-of-rack switches for the FlexPod, but were data center switches that I've got all sorts of other stuff plugged into, that would be something that as we went through that sizing process with the partners, that we'd raise a flag and say, you got 3 ports open on each of those switches. We may need to expand out the uplinks from the fabric interconnects. What do you want to do here? And if they wanted to change the size of the switches, that would certainly be an option that they have.
Okay.
The 40 nodes is a design recommendation, like a best practice. There's nothing physically preventing you from going bigger than 40 nodes. It's just kind of a best practice that we look to when we consider fault domains and that type of thing. So.
Yeah.
And by the way, for those who don't know, that's Brett Seclari. He's the product manager for the Cisco nodes. So
It's all his magic.
yes.
We just get to show it off. Any other questions? The last thing that we had was some key dates. So last week we went public with the announcement. We did a couple different webinars for our partners and kind of introduced what the concept was, the CVD release date, all of those things. As Tom so excitedly retold, we unveiled it in the booth this week. The final retail pricing for that will be available here shortly, and then the product is ready to go. So we've gotten the green light from everybody involved. One of the questions that I got as I walked in the room was, how many POs have you gotten signed this week? I'll just say it's been a spectacularly good week. And the product starts shipping on the 17th of July. So this is the I think the next iteration of our relationship, the NetApp relationship with Cisco, because we're not just taking a reference architecture and putting new fabric interconnects in it or upgrading the version of software that's in it. We've made a fundamental change to the architecture of the storage, to the architecture of the solution, and have really built something that, particularly with customers who don't want to have to guess 3, 4, 5 years in the future about how much performance and capacity they need, they look at this and see something that will allow them to protect that investment and allow them to kind of build out in a much more logical fashion, which has always been what we tried to do with the network design. And now we have, and Cisco gave us the ability to do that with the compute design, and now we've married to it a storage design that works in the same way. So we're pretty excited about it. The customers have been excited about it, and we're really, we're happy to be here with everybody today to show you a little bit of what the nice, boring storage can do inside a sexy network wrapper.
Question that came in
excellent.
from Matt Hato on
I
Twitter.
was going to say, if it's from Howard, I'm not answering it.
No question. He asks, when scaling up to 40 storage nodes, how is congestion managed to prevent TCP Ncast/TCP throughput collapse?
Brett, you want to take that one, or you want me to throw at it?
Hey, Chad Smith's here, by the way, Tech Solutions.
I'll give you the TLDR there is that the storage software itself is designed to do the load balancing, right? So every node we sell doesn't have a theoretical maximum that's CPU bound, right? And I think that's where some of the node-based storage products that are in the market, they don't sell a specific amount of IOPS. Like, we're selling 75,000 IOPS per node. At 75,000 IOPS per node, we have way more CPU than we need to be able to handle not just the customer load, not just the traffic of the customer load, but all of the back-end things that we need to do around dedupe and compression and load balancing and failure detection and all the stuff that we need to. So the short answer is the software balances all of those connections across all of the nodes such that we don't end up getting ourselves in trouble at any one port or at any one node within the cluster. Now, that is not to say that managing the network flow north of us and overloading, say, the Nexus switches because we didn't spec them right for the number of compute nodes that are being tied into the fabric interconnects and we didn't size the trunks right. Like, that's not to say we do ours just fine and we walk away from the whole problem. That's part of what the CVD is there for. So what we're comfortable with is that for the amount of IOPS that we guarantee with each of the nodes that come out, and for the best practices that we built and certified and validated in conjunction with Cisco, that we shouldn't come close to any issues that we would see on a wildly oversubscribed or busy network. So I hope that answers the question. If we want to get into specific things, I mean, we've got both the product manager who built the Cisco node, as well as one of the tech solutions folks who's helped me build every reference architecture that we've done. If we want to dive way under the nerd covers on that one around how TCP handling and signaling gets done inside Element OS, we certainly can. But the easy answer is we would never let a node get into that state. And the design is built so that the top of rack wouldn't get us there either. Everybody around this table can break anything.
And that was
right?
the TLDR.
Right, I'm not. We could break anything that we put in there. The design spec should prevent that from ever being an issue.